What is up, cool cats? This is section 2.4, day 2 of Symmetry. Let's do a little quick review about what we did from before. This is yesterday. You remember yesterday, or last section, we talked about how if we wanted to test for the symmetry about the x-axis, we had this test right here. You just replace y with negative y. And the symmetry about the y-axis would be x, replace x with negative x. And symmetry about the origin, you have to do both. Replace x with negative x and then y with negative y. And then you see whether or not the result is equal to the original. What we're going to do today is we're going to combine our study of symmetry with functions. So day 1 was just graphs. Day 2 is going to talk about functions. And so here's a definition. An even function is a function that is symmetric about the y-axis. That would be this one right here. So before we asked, is it symmetric about the y-axis? Today we're going to ask, is it an even function? And the test is going to be very similar. You replace x with negative x. And then all you have to do is figure out, is f of x, the original, is that going to be equal to f of negative x, which is what you, it's going to be the replacement. An odd function is a function that is symmetric about the origin. So day 1 we talked about symmetry about the origin, and we've had a test for that. With an odd function, it's going to be a very similar test. Replace x with negative x and f of x with negative f of x, so that you see whether or not your expression for f of negative x is equal to your expression for negative f of x. Alright, so without further ado, here we go. Determine whether each of the following functions is even, odd, or neither. Oh, one more thing that I should say is hint. The only function that is both even and odd is the function f of x equals 0. Aside from that, you can say that no function is both even and odd. The only exception is this one. Aside from that, a function is either going to be even or it's going to be odd, or it could be neither. But it can't be both. So that will help us give a couple of shortcuts every once in a while. Okay, so let's take a look at this actual graph. Where's symmetry here? Well, I can see that if I rotate this point around, it looks like this here, and this steep portion of the graph rotated around becomes that steep portion. So it just might be rotationally symmetric around the origin. So that might indicate that it's an odd function. And look, the exponents are odd. So let's actually do the algebraic test. We think it might be odd. The even test asks, is f of x equal to f of negative x? The odd test asks, is f of negative x, is that going to be equal to negative f of x? So, well, we know what f of x is. Let's figure out what f of negative x is. F of negative x is going to be 5 times negative x to the 7th minus 6 times negative x to the 3rd minus 2 times negative x. You simplify all that, you get negative 5x to the 7th minus, well, plus 6x to the 3rd plus 2x. In this case, the sign of each of the terms change, and so that's what you're left with. So the real question is the green part equal to the yellow part? Is f of x equal to f of negative x? And the answer, you can see, is no. The two expressions are not equal to each other. Moving on. Is f of negative x equal to negative f of x? Well, we already figured out what f of negative x is, so let's just compare that to negative f of x. Let's figure out what negative f of x is. That would be negative of 5x to the 7th minus 6x third minus 2x. Distributing the negative, you get negative 5x to the 7th plus 6x to the 3rd plus 2x. So you can see the signs here change. The question is this part, is f of negative x equal to negative f of x? And you can see the blue and the yellow parts, yeah, they are equal to each other. So the answer is yes, this function is odd. We saw that visually with the graph, and now we see it. We saw it in the exponents. That kind of gave us a clue, but really the way to confirm it is to do it with the algebra and to confirm things with the equations. Let's do the same thing again one more time. H of x is equal to 5x to the 6th minus 3x squared minus 7. Well, check this out. I see even exponents. I do see symmetry about the y-axis. Symmetry about the y-axis is very similar to an even function. So maybe this function is going to be even. Let's test it. The even test asks, is h of x, is that going to be equal to h of negative x? Let's find out. Well, we already have h of x, so let's figure out what h of negative x is. H of negative x is going to be 5 negative x to the 6th power minus 3 negative x squared minus 7. Negative x to the 6th power, it's like negative x times itself 6 times. Because 6 happens to be even, all the negatives cancel out, and we're left with 5x to the 6th minus 3x squared minus 7. And so comparing things, we see that h of negative x is going to be equal to h of x. So yes, it is even. The green part equals the yellow part. Now, if it's even, then we don't need to worry about it being odd. Remember, no function is both even and odd. So if it's even, we don't have to worry about a test here. It is definitely not going to be odd. Now would be a good time for me to let you know about your audio check fact. I've got friends in the capital of Alaska, that's Juneau, and they're having a cold time. You can ask me about it if you want, but your audio check is Juneau is the capital of Alaska. Go ahead and begin assignment 2D2. I want you to copy the problem list and do the first problem. And I'll see you in class.